One of the important things to realize when we're dealing with polynomials, the very same rules that we've already learned that guide addition and subtraction, multiplication and division, those all do also guide our rules with polynomials. And so today what we're looking at, we've been adding, subtracting polynomials. Today we're going to take and we're going to multiply polynomial expressions by a monomial. And it's a pretty simple process as long as you remember your operational rules. So what we want to do is look at the very first problem. We're going to look at a series of problems here. And this is the first one. The first one is there on the screen in front of you. It is 5xy squared times 7xy. So on your paper, if you would please write that down. And I'll do likewise. So it is 5xy squared times 7xy. Now, we want to remember a few things, okay? First thing we want to remember is that even if my variable doesn't show an exponent, it is a degree or has a power of 1, and I'm going to jot those down. Y has a power or a degree of 1. That becomes very important. Now, we got to remember our product rule. I think you probably remember if we had a base of A and we multiply it times another base of A, that we're going to take those exponents and we add exponents. That's our product rule for bases with differing exponents. So we're going to just do that. Product of powers property. So to multiply these two monomials, all I'm going to do is I'm going to say, well, it's 5 times 7. 5 times 7 is 35. So that's pretty straightforward. X to the first times x to the first is 1 plus 1, or x squared. So jot that down, please. And then y squared times y to the first is y to the third. All right, so I've taken care of everything. Now, I can only multiply x's times other x's because their bases are the same. And I can multiply y's times y, their bases are the same. And I remember that product rule means to just take the exponents, add them. So 1 plus 1 is 2, 2 plus 1 is 3. 5 times 7 is 35. So I've got my solution here, or my product simplified. Remember, we can multiply unlike terms. All we have to do is be sure we can multiply only the bases that are the same. But we cannot add or subtract unlike terms. So we want to keep that in mind as we're multiplying. Well, let's look at a second example. Okay, this one is a little more involved. It's 18 y squared x to the third z times 3x to the eighth y to the sixth z to the fourth. Now I'm going to put my answer in standard form, and when I do that, I'm going to put my variables in order. In other words, alphabetical order. So when I get ready to multiply these two monomials, the first thing I'm going to do is multiply 3 times 18. I'm just going to multiply the coefficient first. So what is 3 times 18? Harvey? Can't actually hear you, I'm sorry. 54 is correct. So the next thing I want to do is I have y, x, and z. I'm going to actually multiply x first because it comes first in the alphabet. I'll write my answer in standard form. So I have x to the third, and I'll match it with this same base, x to the eighth. I'm talking about the base. I'm talking about the part that does not have an exponent. So x to the third times x to the eighth will be x to the what? The 11th. That's correct. All I had to do was add 8 plus 3. And then y squared times y to the 6th. When I multiply those, what's my exponent? Y to the 8th. And don't forget, z has an exponent of 1, even if it's not written there. So z to the first times z to the fourth is what? Z to the fifth. Let's look at a couple more. Now this is a little different here because remember, we can multiply monomials, no problem. We can multiply unlike terms, no problem. In this example, I'm multiplying 3x times 3x squared plus 6x minus 5. What I'm doing is I'm multiplying a monomial times a trinomial because there's 3 terms here. Remember, unless these terms are alike, I cannot add or subtract them or simplify them anymore. But I can multiply them, and I'll multiply them using the distributive property. In other words, I'm going to multiply 3x times 3x squared, 3x times 6x, and 3x times negative 5. So when I do that, I am going to keep in mind that my exponent, whether there or not, is a 1 for this x and this x as well. So 3 times 3, 9. X to the first times x squared, it's 2 plus 1 or 3. Plus 3 times 6, which is 18. X to the 1 plus 1 or 2. And lastly, 3 times negative 5 is negative 15. And x doesn't have another x to multiply, so it's just negative 15x. Remember, I can't add 9x cubed to 18x squared because they're unlike terms. In order for them to be like terms, both the variable and the exponents have to be identical. You try this one on your own. 2xy times 5x squared y plus 3x y squared plus 7x y. All right, so we're going to start our way and work our way down. Remember, standard form is to put the trinomial or the polynomial in order by degree, so our largest degree first, second, and third, and so on. So we need to do that. As we look at this particular problem, we're going to be sure we put it in order. So it's going to be 2xy times 5x squared y. 2 times 5 is 10. So my very first term will be 10. Then it's x times x squared, which is x to the third. Y times y is y squared. For the second term, it's going to be 2xy times 3xy squared. So that's 6x squared y times y squared, y to the third. And finally, 2xy times 7xy will be 14x squared, y squared. This has a degree of 5. This also has a degree of 5. And then a degree of 4. In the case where the degrees are the same, I'll write my trinomial in descending order, starting with the first alphabetical variable. This is x to the third, so I would put x squared second. These two have the same degree. And yet that's still in standard form. Write this example down. 2a squared times 5b squared plus 3ab plus 6a plus 1. Again, we'll take it term by term. So 2 times 5, 10. A squared times b squared is a squared, b squared. Then 2a squared times 3ab plus 6, 8 to the third b, because remember, a has an exponent of 1. I'll add the 1 and the 2 together to get a to the third. No b to multiply by there. 2a squared plus 6a will be plus 12, a to the third. And finally, 2a squared times 1, just 2a squared. Degree of 4, here a degree of 4. Notice that. We're going to come back and do something with that here in just a second. 12a to the third, degree of 3, and 2. So, since the second term has the same degree as the first term, but notice the first variable is an a, and it's the third power, we're going to list that one first. That way it's a to the third, a squared, a to the third, a squared, and we put our degrees in relative order. So I'm going to write it this way. It's going to be 6a to the third, b plus 10a squared, b squared, plus 12a to the third, degree of 3, that has a degree of 4 there, plus 2a squared, degree of 2. So I would write it in that manner to keep it in standard form. So we're really using the same properties, the same rules for multiplying and adding, subtracting, those sorts of things. The product rule that we already know to multiply monomials by polynomials. Our next step is to take this sort of problem and look at it in a real world situation. And so after lunch, we'll look at that problem and how does this look like? What does this look like as a real problem that we might come across in everyday life?